I'll give a short intro. Melanie Mitchell is a Davis professor, also at the Santa Fe Institute. Her current research focuses on conceptual abstraction, analogy making, and visual recognition in artificial intelligence systems. She's the author or editor of 6 books and many scholarly papers in the fields of AI research, cognitive science, and complex systems. Okay, so if you are ready, you can just go ahead, and yeah, we do see your screen.
Okay, and you can hear me okay?
That's good. Yes.
Great.
All good.
Thank you so much for inviting me to this fun meeting. So I'm going to talk about why AI is harder than we think. And the short answer is because we still don't really appreciate how complex intelligence really is. So the history of AI is one of boom and bust cycles. You know, you can see this in this very rough plot of sort of the outlook for AI, how optimistic people were about AI achieving sort of human level intelligence. And there's been at least 2 AI winters, one of which was right as I got my PhD, which was somewhat unfortunate in terms of job search. But right now we seem to be in an unending AI spring in which people are extremely optimistic. So, you know, examples of this optimism back in 2015, the Guardian newspaper predicted that 5 years later, 2020, we'd have self-driving cars, we wouldn't have to drive anymore. 2016, again, 2020 was somehow a common target for predicting self-driving. Elon Musk in 2019 promised that a year from now, again, 2020, we'll have over 1 million cars with full self-driving, et cetera. And then just this year, he said, I would be shocked if we don't achieve full self-driving safer than humans this year. I would be shocked. Well, I don't think any of us would be shocked since we've seen this pattern. And in fact, here's what one AI researcher said about self-driving. Perhaps expectations are too high. This will eventually result in disaster. Suppose 5 years from now, funding collapses as autonomous vehicles fail to roll. Every startup company fails, et cetera, et cetera. This condition is called the AI winter. Now, this was actually said in 1984 by Drew McDermott, an AI researcher. So you can see the kind of cyclical nature of this thing. Back then, expectations for near-term self-driving cars and many other things were quite high. And about 5 years later, everything collapsed pretty much. So will that happen now? I don't know. We're already seeing some signs of disappointment in the self-driving world, but we'll see how this all turns out. But I do want to say that this idea of over-promising and over-optimism in AI goes back a long time. Even someone as brilliant as Claude Shannon in 1961 predicted that we'd soon see something like the robots of science fiction fame emerging from labs. A few years later, Herbert Simon, one of the pioneers of AI and a Nobel Prize winner, predicted that within 20 years, of 1965, machines would be capable of doing any work that a man can do. Of course, the sexist language of the 1960s. And Marvin Minsky, founder of the MIT AI lab, predicted a few years later that within a generation, which is maybe 20, 25 years, the problem of creating AI will be substantially solved. Well, of course, none of these things happened. And many years later, another pioneer of AI, John McCarthy, said, well, the problem was AI was harder than we thought. You know, back in the early days, people thought that it wouldn't be that hard to create human level intelligence. Well, again, we're seeing a lot of predictions due to the deep learning revolution and you know, other progress in AI. Shane Legg, the co-founder of DeepMind, back in 2008 predicted that we'd see human level AI in the mid-2020s. Mark Zuckerberg said in 2015 that one of the goals of the company was to get better than human level at everything, including general cognition, within the next 5 to 10 years. And Rich Sutton, a pioneer of reinforcement learning, just recently estimated a 50% probability of human-level AI by 2040. And Stuart Russell, in his most recent book, asked, when will super intelligent AI arrive? It will probably happen in the lifetime of my children. And he noted that this was more conservative than that of the typical AI researcher. So these people who are predicting, human level AI, super general cognition, super intelligent AI, I would venture that these terms are not well understood what they mean, if they mean anything at all. And I wrote a paper a couple years ago called Why AI is Harder Than We Think. I probably should have called it Why AI is Still Harder Than We Think, in reference to John McCarthy. And I think the problem is that we really lack intuitions and understanding about what intelligence is. So in the paper, I talked about 4 fallacies that I thought promoted over-optimism in AI. And I'll talk about those briefly. So the first one is that the fallacy that narrow AI is on a continuum with general AI. So this is the idea that when we make some progress in a narrow area of AI, that's predicting progress on general AI. It's a first step. And you can see these kind of press releases of these various programs being called steps towards creating general intelligence. So Hubert Dreyfus, the philosopher, said a long time ago that this first step fallacy, the claim that since any progress, any improvement in our programs, no matter how trivial, counts as progress on this continuum, he claimed that in fact there was a discontinuity in the assumed continuum, and the unexpected obstacle was called the common sense knowledge problem. So I'll talk about that a little bit later. The second fallacy is that easy things are easy and hard things are hard, meaning that things that are easy for humans will also be easy for machines, and vice versa. So for example, a few years ago, the deep learning pioneer, Andrew Ng, said, if a typical person can do a mental task with less than 1 second of thought, we can probably automate it using AI, either now or in the near future. Implying that these easy things, these things that take us less than 1 second of thought, will be easy for machines. A more subtle version of this fallacy was from the original paper on AlphaZero from DeepMind. And they said that Go is among the most challenging domains in terms of human intellect, and implying that, therefore, getting a computer to play Go will be sort of a harbinger of general intelligence AI. Whereas, in fact, Go is indeed very challenging for humans, but games and other abilities that are much easier for humans, like the example Gary Marcus used of charades, playing charades, are still way beyond the ability of any computer program. We've seen recently with the rise of generative AI, generative language, generative images, that there's been a lot of very optimistic coverage in the press and in among researchers. So, the Washington Post wrote a glowing article about how AI can create any image in seconds, bringing wonder and danger. And New York Times recently wrote an article, an opinion piece, saying we need to talk about how good AI is getting. And these referred to things like OpenAI's GPT-3 program, which indeed can, as everybody here knows, can generate amazingly human-like text and often does very well on reasoning benchmarks, and has been seen as many people as a step towards general intelligence. But it turns out that if, it can write an essay on the causes of the Civil War, the American Civil War, But if you ask it very simple physical reasoning questions, like this one, this is my prompt. I put a green box on top of a blue box. Okay, imagine that. I put a yellow box on the green box and another red box on top of that. I then took off the red box and put it beneath the blue box. What is on top now? Okay, so you probably have a mental image and can answer that what's on the top now is the yellow box. But if you ask GPT-3, it gets it wrong. And if you ask what's on the bottom, well, you could probably take your mental model and imagine that the red box is on the bottom, but it also gets that wrong. So these simple kinds of physical reasoning abilities are lacking. So one of the examples of easy things are hard. These models also have problems with things like negation. If I ask GPT-3, write a sentence that is not about ice cream, it writes, I'm not a fan of ice cream. Or even these generative image models like DALL-E, which can, as the Washington Post claimed, create any image from text. If you ask it the same kind of idea, a yellow box on top of a green box, which is on top of a blue box, it can never generate that. I tried many times, and here's the kinds of things it generates, because it doesn't have this concept of the sort of physical placement, doesn't understand these prepositions. And like if you ask it the negative problem, give me a bowl of fruit with no apples, it's unable to do that either. Every bowl of fruit it produces is rife with apples. So these kinds of things that are easy for humans turn out to be hard for machines. And I don't think anybody's been able to train these systems to do better on these kinds of things that are hard to get examples of in the training set. So this goes back to Moravec's paradox, that it's comparatively easy to make computers exhibit adult performance on things like intelligence tests or playing checkers. You know, this was written actually before computers were beating chess players and Go players. And it's difficult or impossible to give them the skills of a 1-year-old when it comes to perception and mobility. And I'll add common sense. The third fallacy was what I call the lure of wishful mnemonics, a term I got from Drew McDermott paper from 1976 that was about how people in AI would use human language, anthropomorphic human language, to describe what their AI systems could do when the AI systems were actually not able to do those tasks in a human-like way, such as Watson reading all of the healthcare texts in the world, whereas the word read implies understanding. Or Watson understands context and nuance in 7 languages. You know, these terms are something that we're using in this very fluid way, whereas they have a lot of human baggage that comes along with them. Or even saying that AlphaGo has a goal to beat the best human players, not just mimic them. So a computer program doesn't have a goal in the human-like sense. And yet using this language tends to convince us, even researchers themselves, that these machines actually have something that they really don't. And here's a headline recently: Google unveils an AI that's able to create knowledge itself, that learns on its own, using these terms like knowledge and even learns, that are really quite different than what the humans have when they have knowledge or when they learn. So even the names that we give our benchmark data sets, such as a reading comprehension data set, or a general language understanding evaluation, or a cognition level visual understanding. So these are the names that we have given on benchmark data sets to evaluate AI programs. And when they actually outperform humans, as they do on these systems, these benchmarks, how can we blame people from thinking that they have actually achieved general language understanding or visual understanding or reading comprehension? This is the GLUE, general language understanding and evaluation, and its successor, super GLUE. And you can see humans right now, this is the human baseline. It's below 6 different deep learning language models. So how can we blame people for assuming that machines are better than humans at general language understanding? Well, it turns out that those are wishful mnemonics, that these systems are able to do well on these benchmarks without the ability that the benchmarks are named after. My final fallacy is the idea that intelligence is all in the brain. So this is the idea that if only we could get the AI to sort of brain scale computing capacity, we'd be able to achieve intelligence. This is this idea of a brain in a vat, achieving intelligence somehow. And you see this in headlines, sort of asking about how AI compares with the computational capacity of the brain, or human brain scale AI, the massive AI chip that has the compute power of a brain, and so on, assuming that if we could only achieve that, we'd then get to AI. And even people in the field, these are 2 prominent AI people on Twitter, saying that all we need to do is scale up these large-scale pre-trained models to achieve general intelligence. Okay. But this ignores a lot of work in cognitive science, which shows that the brain isn't the only thing that's responsible for our intelligence, that our bodies and our interactions with the environment are perhaps equally as important. This is, of course, very controversial, but it's something that people in AI are very slow to take into account. So what are the major open challenges for AI to get to more like human-like intelligence? Well, here's some of them. Things like few-shot learning, generalization, abstraction and analogy, understanding, and this elusive common sense. So let me give you a couple of examples of that in my last few minutes. So it turns out that the most common accident for self-driving cars is that humans rear-end them. What happens is that the car is driving along, human driving behind it, probably too close as humans do, and the self-driving car slams on the brakes unexpectedly, and the human behind it crashes into it. Because the human is expecting the self-driving car to drive like a human, whereas the self-driving car perceives things in the world as obstacles that no human would ever perceive, such as, a floating plastic bag or a tumbleweed. Here in New Mexico, we see things like this. And any human would know that you don't need to stop for this kind of thing, because we understand the physics of the world and how our car will interact with different kinds of objects. We know that birds are likely to fly away, or even, that we shouldn't drive over this pile of glass in the road, or that this snowman in the middle of the road will not run across in front of our car, because we have a vast understanding of how the world works. And this is what you might call common sense. And in fact, this is something that people in AI are pushing hard on. Paul Allen, before he died, started an institute to study common sense in AI. And the US Department of Defense is pouring a lot of money into what they call machine common sense. But it's very difficult. And this is an example that I'll end with. This was an example from a blog post by Andrej Karpathy. He is a deep learning researcher who used to be the head of AI at Tesla. This was when he was still a grad student. He wrote this blog post about computer vision and AI and how far away we are, using this fantastic example of understanding that we would need to make sense of this image. So yes, what would it take for a computer to understand this image? And, there's just a vast amount of things that we know about intuitive physics, about humans, what makes something funny, why people stand on scales, how a scale works, what kind of room this is, a locker room, that this image over here in the mirror isn't another person. And it just goes on. And we know that this is like a joke situation. We're able to abstract and so on. It's a great blog post. I recommend it for reading it. It's still really quite relevant. So I'll say, in spite of enormous progress in specific areas, AI systems are still far from having anything like these general human abilities. And I think this is something that a lot of people in the field don't appreciate. And it's what makes AI still harder than we think. So you probably know that, the first meeting of AI was in 1956 at Dartmouth, organized by these luminaries. And they had some amazing goals, like during the summer, they would figure out how to make machines use language, form abstractions and concepts, solve problems reserved for humans, and improve themselves. I would say this is the most still open problem. But interestingly, Eric Horvitz, who's now the head of Microsoft Research, said back in 2015 that one might even say that this proposal, if properly reformatted, could be resubmitted to the NSF today and would probably get some funding by some excited program managers. So indeed, a lot of problems in AI are still quite open. And I think that people are being over-optimistic about how soon we're going to get to anything like human-level AI. Thank you for listening. I talk a lot more about this in my recent book on AI. Happy to answer any questions.
Yeah, thanks a lot, Melanie. There are a few questions in the Q&A. The first I'll ask is, does AI need an artificial, in brackets, artificial body to evolve from weak to strong?
Sorry, does AI need an artificial body to evolve from weak to strong? Oh, I see, weak to strong AI. Exactly. Okay.
Yeah, and whether it needs an artificial a body, and whether it could be an artificial one, but some kind of body. That's the question.
Yeah, I think that's a great question. And, nobody knows the answer because, first of all, we don't know how to define sort of strong or general AI. I think that nobody agrees on what the definitions are. And we also don't know how embodied we need to be. So today, an embodied AI means like an agent working in a virtual environment online, and like in a computer game. People would call that embodied, but of course that's not having a real body. So do we need to build robots that actually interact with the world? I think no one really knows, and that's very much an open, controversial question.
Yeah. Okay, the next question is, most AI research at university these days happens in deep learning, that is pattern recognition or misting. This is very remote from McCarthy's characterization of AI. Isn't the rebranding of machine learning as AI perhaps the most fundamental fallacy?
Yeah, I mean, it's a funny history because machine learning initially was opposed to AI. AI was defined as symbolic approaches, not neural nets. And you can see this explicitly in the writings of the early AI folks. So machine learning was explicitly, different conferences, different journals, different approaches, relying much more on statistics, and then suddenly machine learning equals AI. So I don't know how this evolved, probably due to economic forces and the sort of commercialization of a lot of AI technologies. Now there's a lot of talk about how deep learning has limitations that only can be overcome by integrating it with more symbolic approaches, but nobody's really come up with very effective ways to do that. So, these different camps of AI have been going on forever, and it's hard to say what's maybe something completely new is really needed.
Okay, another question is, do you have any insights to share on what the different factors are that lead to such an interest in creating an AI with quote unquote general human abilities? What are the incentives involved and the major risks as you see them?
Right. So why create human-like AI? Why not just create unhuman-like AI that can do things that we have problems with? And that's something we've done, of course, already. We've created AI systems that can navigate for us in our cars, that can transcribe our speech, that can figure out how to predict protein structure and all kinds of things. Very much harder for humans. So I think that there's domains in which we really don't want the AI to think like us. We want it to think differently, like in perhaps scientific applications, where it can understand patterns and it can come up with patterns and data that are things that we would never have thought of. But in human domains in which the AI is interacting with us, like in driving, for example, we do want it to think like us. We do want it to have the same kind of common sense that we have, or else the systems will be unpredictable, and this is going to be a big problem. And we've already seen that happen. So I'll just say that, there are certain domains in which we probably need machines with common sense like humans, and other domains where we don't.
Okay, I will ask also a question from one of the organizers, Tomek Korbak. So his question is, how far could plain scaling of existing AI techniques, for instance, unlabeled data, transformers, lead us? Can we automate the majority of intellectual labor using language models?
That's the billion-dollar question. $1 billion, I don't know. This is something that companies like OpenAI are putting all their bets on scaling. And we see that these systems get better and better in some sense with scaling, meaning increasing the size of the networks, increasing the scale of the data. But one problem is that the benchmarks that we use to assess this progress often have problems in that they allow for shortcuts, meaning that if you ask, you say, okay, this is a reading comprehension benchmark, I'm going to test my language model on it. Language model does great, except it doesn't do it in the way I wanted it to do it. It uses like statistical correlations in the data that are not reflective of comprehension in the sense that we want it to be. So whether that kind of approach can, if you have more and more data, actually match humans in every sense, I don't know. I think that's still an open question. I would bet against that, but I've been wrong before.
Yeah. Okay, so I may also ask a final question before we have a short break and go into the panel discussion. So you've been saying right at the beginning that we have a limited understanding of the nature and the complexity of intelligence, which is why AI is harder than we think. And I would ask you, with the knowledge that you have at that point, what would be your best working definition of intelligence? You've been naming a few things, but maybe you could elaborate on this a bit more. And also, how would you reason about that in the first place? I'm now thinking about Gael's talk, for instance, or also Conrad's, which have been a lot about complexity that we may not be able to understand in any intuitive way. So yeah, but what's there to do if the only thing we have is our intuitions and the phenomenology of our cognition? So how would we reason about yeah, the ingredients of intelligence, yeah, and the possibility that it's actually too complex for us to grasp.
All in the next 30 seconds, right?
Exactly.
Yeah.
Okay, yeah. I see, it's a big question.
Yeah, it is a big question. So
we can also move that to the panel discussion.
I think that would be a great question to move to the panel. And I'd love to hear everybody's thoughts on that. I think there's many kinds of intelligence, and the word perhaps thinking of it as something, as a thing that we have to explain, perhaps is misleading us, since it might not be a single thing.
All right. Okay. Yeah, I guess then everything else in the panel discussion. Yeah, again, thanks a lot for your talk.